So natural language processing we understood, right? Why natural language processing? Natural language processing is to convert your text into numbers. And then you can apply either machine learning or deep learning. Depending on the way you converted, you may apply machine learning or deep learning. We actually have seen it. If you are just converting your data into numbers, then each document will become one row. If you have m number of documents, Mary number of documents, then you will get m number of rows, and it's a two-dimensional matrix. Total data will become a two-dimensional matrix, and you can apply machine learning or deep learning. But when you convert each word into a vector, that time the total data becomes a three-dimensional matrix, because each row becomes a two-dimensional matrix. Because in each sentence there will be multiple words. Each word is a one-dimensional vector, right? A vector, right? One two-dimensional, or vector means, right, it will have rows and columns, right? So total data will become three-dimensional, two-dimensional thing. This whole thing will become two-dimensional. If you have these kinds of words many, then the total data becomes a three-dimensional matrix. Okay, so when the data is three-dimensional, you no way can use machine learning. You should go to deep learning. So why and how we'll look into it. But basic purpose of NLP is to convert your text into numbers and meaningful numbers. When we are converting text into numbers, the process we took should not damage the data, or should not lose the essence of the data. So that's what we have seen. If you are trying to classify document types in a bank, then bag of words is the best approach. But if you are trying to look at maybe try to find entities or names of people based on certain activity. Certain activity means maybe submission, or requests, or these kinds of things, right? So somebody kept an application to request for something. In that application, in that letter, you will have some words related to request. So this is semantic. Some people may write, I request, some people may not use request word, but the whole letter may be requesting. Right? That kind of semantic similarity you need to find out. Then the word embeddings are going to be very useful. So the problem you are trying to solve and the data set you are working on decides which approach is right. There is no right, there is no wrong. So the approach depends on the data set. So natural language processing is a bunch of techniques, processes, and algorithms that deals with the natural language and make it understandable by the computer. Make it understandable by the computer. Machine learning algorithms are the ones which are actually making the computer understand the human-like capabilities. Most common tasks are tokenization, text normalization, converting words, characters to meaningful numbers and vectors. Right? I said vectors. Right? I am actually coming back to that again and again because that's the most prominent approach. And if you take word embeddings or transformer networks, you need to remember these words. The terminology is very important. Word embeddings or transformer networks. Those are the ones currently industry is using, and the people who know that are needed more. Okay, so converting words, characters into meaningful numbers or vectors. This is the ultimate thing. Once these two are supportive activities. Tokenization and text normalization are supportive activities. This is the ultimate activity. So we are going to practically see how to implement it. I have taken NLTK as the basic approach here, and Stanford NLP code is not working now. So I'll show you the resource, and you need to make it work and come back. It is not a big deal. I'll show you how to make it work or where to find it. So pandas, numpy, I have taken regular expressions also. I'll show you regular expressions tomorrow. And matplotlib. Right? Tokenization. Tokenization is the process of splitting input sequence into tokens. The words are example of tokens. Most generally, 99% of the times, words present in the text are the sentences. A word is a meaningful sequence of characters. These are all definitions. No need. Right? Word boundaries in English are space or punctuation. In English, it is. Right? Depending on language, the word boundaries will change. In German, there are compound words which are written without spaces. Some languages, this whole thing is a sentence, not a word. This whole thing is a sentence in Germany. It stands for insurance companies which provide legal protection. Right? This whole right. So can I use the same tokenizer? Right? I'm saying word func tokenizer here. That's a class which actually tries to divide this whole sentence into words. When I was explaining, I would have used space can be used or split. On string method, split can be used as a tokenizer. But no, it is not going to fit for all languages. Depending on language, the tokenization will differ. Okay. And Japanese, there are spaces, no spaces. Japanese, no spaces. But if you look at this sentence, right, you can read that. That's the sentence. Right? If you know the words, individual words, you can read. So there must be distinct words for a distinct meaning in Japan, right? But in most of the languages, you will have same word, same spelling may have different meaning, right? But depending on the context, they it will have different meaning. But in Japanese, they must be having each word one meaning only. That's where, right, if you look at this, but you can still read this right, read it right. So that's the sentence here. So like this, if you know individual words, you can make out what is what the whole sentence is all about, right? Like that. With different languages, different problems will come. Why am I highlighting these? Currently, NLP has got some capabilities. NLP is unable to solve some problems. But industry, the people, business people have expectation that NLP can solve everything. Right? If you pass a text, it will understand like a human being. No, it is not. So we need to understand limitations also. While learning a technology, we should understand limitations also. Why understanding limitations? Two benefits of understanding limitation. One, when we are proposing a solution, we'll know how far we can build solution. We can educate the client and set their expectations. That is one thing. Second thing is there will be technological upgradements in these areas where we are trying to see problems. Maybe in 4 or 5 years, right, we'll have solutions for most of the problems we see now. So if you take NLP, right, it'll be able to solve 80% of the problems of industry. 20, we still have research going on. So I'll show you the capabilities, the strengths and weaknesses, all of it in NLP. I'll show you. Okay. So different languages is one problem. Whenever you are trying to process documents in big organizations, it is not just going to be English. It's going to be in our European languages and Arabic languages and all that. So one of our students, two of our students are working in a bank from Kuwait, and they need to build chatbots for Arabic. Right, that's going to be a bit challenging task. Right, like that right. Why am I trying to explain these things? Like this, you may encounter problems. Okay, so when I explain something, you need to explore more and try to find out. From here onwards, I'll explain maybe 95% of the concept. 5% you need to explore. Okay. So there will be different things that I may not explore or explain. Two problems are there: explore and explain. You need to explore. So I have taken a sentence here. This is a document, I call it as. Okay. Here the document is very small. In general, documents are going to be between 1 page to maybe 1,000 pages. If you are trying to understand a book, then it's going to be 1,000 pages. Understanding a book is called a summarization, text summarization. If you read a book, if I come and ask you what is that book about, you will be explaining that whole thing in. You will be explaining that whole thing in. Give me 1 second. Door close. Close. So now you will be explaining that whole thing in maybe 5 10 words, 5 10 words or maybe 10 sentences, right? So that's summarization, right? So text summarization is not that sophisticated in NLP. Okay, you cannot do uh, exact text summarization. Okay, so I have taken this sentence and now I am going to do tokenization. See this here, I said tokenization, text normalization, and then converting. So when we look at the example on that day, and on Friday, we have seen one example, right? So in that we have done all this, but there are different techniques to do it, different modules to do it. We are going to look at different ways of doing it. Is that needed? Yes, it is. I will explain why. So if you see this, I have taken the data and then tokenized it, right? How did I tokenize it? Using uh, where is this? Hmm, Where is it?
You used split.
Where is it?
Little bit below. Yeah, little bit below. Yes.
Oh, these are stop words, right? So here, okay,
Yeah.
I'm getting confused. See this here. Yeah, I used split to split it, but in English it may work. It may work. I am saying, right? So there will be some problems with split. So because of some problems, right? There are tokenizers. So let us see. Tokenization we did and text normalization also we did in this particular loop. Okay, and then we converted the text into numbers and then we applied model. At a high level we looked at it, but
So
in
what is
detail,
normalization over here?
this whole process is called as normalization. Splitting data, converting into lowercase, and then stemming or lemmatization. That whole process is called as text normalization. I'll show you. There are
Yeah.
steps in there. Basically, we have seen all of it, but we are trying to explore in detail. What exactly, how many ways we can do it, and which way should be used. Okay. So here I have taken this text and then using word punct tokenizer from NLTK. NLTK is not used in production. That we need to remember. But why are we looking at it? Because in some interviews, right, people don't know that NLTK cannot be used in production. They may ask questions about NLTK. Natural language toolkit. This is mostly for experimental purposes and research purposes only. In production, we will not use because efficiency is low. Okay. So WordPunct NLTK tokenizer has got many tokenizers. But WordPunct tokenizer is a split basically. Word punctuation, right? It is going to split data based on the spaces and the punctuations. If you see this here, Andrew Ng is Datajango's guru, isn't it? Andrew Ng is a professor in Stanford, San Francisco, California, right? So this is a sentence. When I did a word punct tokenizer based on the spaces and punctuations, see this Andrew Ng it identified as a separate thing. It is actually a named entity we call it as, right? That whole thing should be identified as one. It did not identify and it split it as two tokens. And then Datajangos is one sentence, one word. It is not two words. So based on punctuation, it divided. And Guru, right? Isn't it also right? Isn't it also no? Isn't it should be? Isn't it is like is not, right? So it should have done is not or kept it as intact as isn't, right? Like that. And if you look at the end, Stanford University again is a no named entity. We call these nouns as named entities, right? Nouns are the entity names, right? The college names, the person, people names, drug names, device names, right? These are all called as entities, right? So San Francisco is also one entity. One city name it is. It should have to tokenized it as one word rather than one phrase, we call it, right? Two words, two or more words combined is called as a phrase. Okay, so these are all terminology used in NLP. So here word func tokenizer is not doing it well, right? How did I do it? I created an object, then took the object and then did tokenize and passed the text, and I got tokens. The same thing I did here with split. Simply, if I did split right, it actually splitted the sentence into words. But why are we using this? There are other ways. Tree bank word tokenizer. Now pen tree bank is a corpus. What is corpus? We'll see in a moment. The pen tree bank dataset. Pennsylvania University, University, Wharton University, or Pennsylvania University is called as, those guys actually created this corpus. What is a corpus? The corpus is a labeled text data set. Okay. What are all kinds of labels we can have? If you look at this, if I know already, Stanford University, a single phrase that actually denotes a university, and San Francisco as a location, right, of a name of a city. I means the word func tokenizer already knows it. It would have tokenized it as individual words, right? Because it doesn't know, it actually took space and punctuation as the delimiter and tried to divide the words into the sentence into words. But if it already had known that this part and this part are one unit, it would have divided that like that, right? So pen tree bank tokenizer, it actually looks into some data which is already having these kinds of tokens. Okay, so here it did not do it well, but pen tree bank actually, they took novels and the newspapers from different domains and tried to label them. How do they label them? They label them as POS tags, we call them as parts of speech tags. So if you look at a sentence, there will be parts of speech, right? This is noun, right? This is also a noun, right? And a professor is like professor is a adjective, right? It is going to tell something about a person is adjective. Is that right? What is the adjective? Do you remember? Guys?
So describing words. Describing about it.
Describing something, right? So this is adjective, right? Is this adjective for Andrew, or this is also a noun? Profession, right? Profession is a noun.
I think it's a noun only.
Don't know. Noun. Noun
There
and
are different kinds of nouns actually. It may be a noun as you understand it.
Yeah. Okay. So like that, so the corpus will have some labels assigned to the text, right? Those labels are assigned by people, right? People like pen tree bank corpus. The professors from Pennsylvania University took many data sets or many documents and then they labeled it. Okay. Is the noise very high? The hammering?
Not much.
Okay, good. So, right, so the tokenization actually did, but it is not right. So why am I trying to show this is the tokenizers will use statistical models. We call them as language models. So this is all terminology I am trying to dump now, and I am going to demystify this whole thing in our course. It takes 1.5 months to demystify the whole stuff. Okay, so there will be language models, right, which built on top of the labeled data. Okay, labeled corpuses are created by universities and professors, or maybe industry also, right? If you look at Spacey, this is a popular library. Popular NLP library that actually did lots of work on, labeling the data and stuff, and it supports around 69 languages. We'll focus more on Spacey, right? So this is 69 languages it supports. And basically corpus means somebody labeled the data. That labeled data is called as corpus. Based on labeled data, the NLP experts, like linguistic experts, build language models. Using language models, there can be tokenization done. Okay, sentenceization, tokenization, text normalization can be done using labeled data. Labeled data, right? Those text tokenization, sentenceization, and text normalization modules are called as natural language models. Language models, they are called as. Language models are statistical in nature. When I say statistical in nature, if Andrew has appeared in 100 documents, and maybe 1,000 times, maybe 100 documents and 1,000 times, out of 1,000 times, 700 times it is noun, 200 times it is verb, and maybe 300 times it is adverb. Then in a new document, if Andrew is found, you specify that as a noun, because in the corpus most of the times it appeared as noun. Got it? That is a language model I spoke. It's a probabilistic language model. Did you get it? Should I repeat? Should I repeat?
Yes, sir. Can you repeat?
So Andrew is a word, right? So I need to find out whether it is a noun or a verb or a adjective or adverb or article or whatever, right? Do we need that? Yes, we need that. I'll explain why we need that. It's a parts of speech tagging, we call it as POS tagging, parts of speech tagging. Okay. So to do that, we need help, right? How do you know Andrew is a noun as a person? How do you know Andrew is a noun? How do you know Andrew is a noun?
Yeah, maybe his name appeared in many articles or in discussions, etc.
Yeah, name appeared, and we by looking at the context also we can understand as human beings, right? Or maybe initially while studying, some names were induced into your mind, right? May not be Andrew, John, maybe Rama, maybe Krishna, like this. Many names were induced, as part of your education, or as part of you roam around and talk to people and ask names, right? That way even if you see some Arabic or maybe Italian or German name, you will be able to sense that it is a name. It is not something else. Maybe mostly you may be able to sense it, but may not be able to. You may not be exactly sure that it is name or not. Why? Because you have been induced with many names, and you know the context, right? When you study the whole thing, you know the context. That's where you're actually able to understand that as a name. So it is a language model, basically. In your mind, right? It's our Andrew in many places as a noun, and now you identify that as a noun. Same thing, right? The corpus will have thousands of documents with the labels assigned to the specific words. When a new sentence comes in, you take the word and try to look into the corpus. Look into the corpus and then see whether this is noun most of the times or verb most of the times or adjective most of, whichever is most, you specify that as the that particular thing, right? Andrew appeared 700 times as noun in the corpus. You are saying Andrew is a noun, right? That is a language model. It is a unigram model, you call it as. I am dumping too much today, but we'll see clearly, what is language model and what is unigram, bigram, trigram, right? All that we'll see. But today I am just trying to, for last couple of days, I am actually trying to induce the NLP at a high level. Okay, you got it, right? So Pantry Bank tokenizer will tokenize data based on the corpus. Right? In the corpus, they would have tokenized the data and gave it. So see this here, isn't it was split in a different way. Is int it. The intelligence came to this particular tree bank tokenizer because it is based on the corpus created by Pennsylvania University. Corpus created by Pennsylvania University. When I say corpus created by, corpus means labeled data. No, it actually labeled the delimitation also, right? Division also. So NLTK has got some tokenizers, and SPACY has got some tokenizers, and there is one more, most recently coming up, Flare. Right? It is from 2018-19 time frame they have started it, but this is more powerful when compared to SPACY also. Right, this particular thing powerful in the sense it uses an approach called as character based deep learning models. Okay, character level deep learning models. Most of the cases it works well, right? Some cases spacey works well, but spacey is more sophisticated compared to Flare. So we need to experiment on these two modules, basically with different languages also. Those are the exercises we actually have to do. Okay, so I'll give you the exercises. So now this is tokenization, and then white space tokenizer. White space tokenizer is like space only, right? It doesn't care, but whether it is a punctuation or whatever, it just splits the data. But Stanford University and San Francisco should be considered as one. I'll show you. When we use spacey, it considers the whole thing as one, in named entities. And here, right, this nodes is old. This Stanford has got its own parsers and the tokenizers and NER tokenizers and all. Most recently, Stanford Core NLP changed their module name as Stanza. So this is Stanza. Give me one second. So Stanza is another module, right, which is also more popular, right? So tokenization and sentence splitting, multi-word token expression, lemmatization, POS and morphological tagging, parts of speech tagging and morphological tagging, dependency parsing. Dependency parsing means it's a word structure we can understand. What is the root word and what are the dependent words we can understand. We'll see all this. Name entity recognition. These are all the processors. And when you pass raw text, the stanza can actually give you the output, right? Doing all these steps, it will give output. So we will actually experiment with all three: stanza, spacey, and flare. Okay, if you know these three, right, industry needs these three, and you're good to go. You can solve many problems. So this code part, Stanford core NLP is old code, and you will not be able to execute this. We need to install Stanza and then do it. Pip install or Conda install will work. Okay. So tomorrow I am going to log into Unix machine. This is Windows machine, and all the modules are not working here for me because I have installed different things there. Right. So tomorrow I'll actually show you how to execute these things. Stanza and Spassy and all that. Okay. So I have taken a document here, big document. So we actually started a product and stopped it because of other financial reasons on healthcare, where we were actually trying to extract data from the web and trying to identify different drugs, devices, and the people names, name identities basically. Right? And from that data set, I have taken one document. Right? Then I am trying to do some regular expressions, so trying to find whether there are new line spaces, there are returns and tabs and all that. I am trying to remove them. Or when you take data, right, you may have to do some kind of cleanup. Right here I was actually trying to remove this content media, whatever, this whole thing I am trying to remove. I wrote some expression here and then applied that regular expression, right, and then substituted regular expression dot substitute. Wherever you find this expression, replace that with blank space in sample text. Right. So that's find all will actually find wherever all it finds. Right? It is just to see whether that particular expression is working or not. Once it is working, right, you can actually use a re.sub to replace. So this also comes under data the text pre-processing. Okay, natural language processing only. We may not be using any module from any of the libraries, but still it comes under natural language processing because we are processing it. Regular expressions help you a lot in cleaning up data or finding different things from data. Okay. So from NLTK whitespace, regular expression tokenizer is also there. You can write like this, right, to replace text using whatever text you want, or you can actually tokenize the data using regular expressions also. That capital S plus is actually the words, right? Wherever you find word, multiple characters, you take that as the tokenizer. It is a space tokenizer only. So you can use regular expressions also. If you want to tokenize only specific words with some kind of pattern in there, you can use that. In NLTK, we have, even in Spacie also, we have regular expression tokenizers. So then next thing is space tokenizer. These are all same thing. This code is not going to work now, so I have to change it. I'll change it tomorrow. And then in NLTK, there is a frequency distribution method. No need to look at that. But basically what we are trying to do is, we are trying to look at how many times each word occurred. This is an important analysis we will be doing in many of the documents. When you get data, right, when you get either images or the text there, first thing you need to do is you need to open maybe 100 200 documents and look at them. Look at them in the sense you need to read through and and try to understand and things like that. Right, that is the first step. And the next step is you take a document, you extract the data, right? When I say extract, right, the document may be a PDF or a Word document, or maybe present in a CSV file, right? So you need to extract the data from the PDF and then try to see how many, in each of the document, what is the frequency count here. If you look at this, right, the comma appeared 71 times, end appeared 56 times, the appeared 48 times. If you are trying to do sentiment analysis, right, so or you wanted to identify the topic it is actually talking about, leadership is there, right, gamma is there, right, IFNV is there. This is some technical, the medical word. IRAK4 is there. That may be another medical word. Right? Those words actually appeared only once. But if you look at these and the, of, full stop, in, right? These appeared many times with. Right? What you call these words as?
Stop words.
Stop words, right? So you can understand how the data is distributed in the document. In one document, I'm showing, but in real time, when you are working with, you need to open documents, read them as a human being, and then try to tokenize it and look at the frequency counts of words. See this here, Pfizer. This is a company name, right? This is not stop word. So if you are trying to remove stop words, right, you can create by looking at maybe 50, 20, 50 documents, or maybe write a program that actually shows you the words which occurred more than 5 times, right? And see where you should be considering, 11 onwards you should be considering, or maybe below all are not, you should not be considering. So based on the frequency count also, there are methods, there are modules that I'll show you. When we do word to vector, word vectorization module, it actually asks how much frequency you should be considering. Above 11 or above 12, or maybe below 11 and above 2, it lasts the range, right? How many times the word should appear to consider it to convert it into vector. So how will you know? By looking at the data and by doing this analysis. Frequency counts is a important thing to do to understand how the data is distributed, right? Got it? Where we will use, I'll show, but did you get the concept?
Yes, sir.
See, NLP is a confusing concept. It is not a great concept. The people who wrote books have written in such a way that it should be confusing. So I am actually trying to combine everything and try to talk, and then again we'll talk about individual components. And you need to stay connected. This whole last 3 days, right? The Wednesday, Thursday, Friday, and today, maybe tomorrow also, right? They're all like, as a whole I am talking. I'll be talking about individual components, then you need to connect them. If you are not able to connect, stop and ask, because at one point in time NLP becomes like, why this guy is talking like this. Okay. So here we are actually looking at frequency counts to understand where exactly the important word stopped. But you see, is, other, again, these are all again at these may be stop words. You don't know, right? So sometimes, however much care you take, sometimes stop words may enter into the data because you are handling millions of documents, not one or two. Okay, but that's okay. However much you can clean, you clean it. The rest will be taken care by the NLP model. In some cases, right, these one-time occurring words also may not be important. So you need to decide the lower limit and upper limit of the words which are important. Okay? So frequency distribution, you call it as this whole thing is frequency distribution. Okay, and then low frequency words. I actually wrote some methods to do that low frequency, high frequency, and all that. You can write your own. Right, tree bank tokenizer, punctuation tense tokenizer. That's okay. Right. So text normalization. What is text normalization? Find root words with stemming or lemmatization to reduce number of features. Can cause case conversion and acronyms. Give me 1 second. I think there is some. Give me 1 second. Okay? Give me also. Okay, we'll see that later. Okay, I'll show image, separate image there. Right. So normalization of terms, right? Map single multiple terms to multiple tokens to terms. Right. Example, what is normalization? I am trying to explain, and then we'll talk about all the theory. We already have seen it. Okay. So example, right? Window, right? Windows. So actually, you can take multiple words here and map it to one. No need to take all these words. I told you this, right? As part of lemmatization and stemming, we try to find the root word to reduce number of columns, number of features in the data, one thing, and then increase the concentration of the feature, or reduce the dilution, right? So normalization is language dependent, right? It is not same for all languages. Case folding is another term used. Reduce all letters to lowercase, all total data into lowercase. That is one more thing. This is called as case folding. Okay. Synonyms. If you look at an article which is written on automobile, right? Sometimes it may be written as automobile, sometimes it is written as vehicle, sometimes it is written as car. You need to find out all these words and replace them with car. Right? This is another task. Right? Need to map car to automobile, vehicle, whatever. Right? Homonyms. Right? Same words but different meaning. This is a big problem. This is a big problem in NLP, and there are solutions. But still, sometimes there is a concept called as word sense disambiguation. Disambiguation. Word sense disambiguation. Ambiguity means confusion, right? Word sense, how the word is actually sensing, and need to disambiguate. There may be ambiguity, but you need to disambiguate by converting the number text into number. That's the problem. Then there are some problems there, but the word vectorization and transformer networks will solve the most part of it. Okay, saw can be a past tense and right, like I saw a bird in the woods, or I saw a bird in the trees, and the sawmill is cutting the wood. Right, both spellings are same. The saw spellings are same. In one place, I am trying to explain that I saw something. In another place, a machine is cutting a wood. Right. So that is if you try to build a bag of words model, there will be one word sa. The count will come in both sentences, count will come, but the meaning is different. So model will understand the pattern wrongly, and may predict wrongly. So to avoid that, right, you can actually do POS tagging, parts of speech tagging. I saw a bird in the woods. When you do parts of speech tagging, saw will get verb. The sawmill is cutting the wood. In that, right, saw will get the noun. That way you will get two different columns. Verb saw will get one column, and noun saw will get other column. Got it? And then counts will be different, and the pattern is going to be different, and the model will understand. So you can use POS tagging to disambiguate words when they are same word is giving different meaning. So as part of text normalization, right, you understand data and try to convert the text. Okay, spelling mistakes. There are algorithms to correct spelling mistakes, and then stemming and lemmatization. So in this normalization, here you may use stemming and lemmatization, or manually also do, right. This car to automobile and other mapping should be done manually only. So this is normalizing text. This image is not coming. I don't know why. Let's see. So stemming lemmatization we have seen, and where to use what we have already seen that. Right here there is some concept I wanted to explain. So more on data processing, the task and activities differ based on sentences. For text summarization task, remove repeated words, remove long sentences, with stop words and high frequency. So when you are trying to do text summarization, right? I said summarization means a document is given to the model and it need to explain the whole document sense, total understanding in maybe one paragraph. That is text summarization. In that, repeated words you can remove and stop words you can actually remove. Okay, in grammar correction system, if you are trying to build a grammar correction system, we should not remove stop words. Depending on the use case, right? You should not remove stop words. Stop words make a lot of sense in grammatical mistakes, right? Can remove math equations or HTML tag, right? This may not happen there. Need detailed analysis before removing, abbreviated words. Right? Abbreviated words means FII, right? For your information. These kinds of abbreviated words should we be removing or not? That should be decided, carefully. Sentiment analysis. Remove casual words. In sentiment analysis, right? If you look at the document here, the above, if you are doing sentiment analysis, right? No need of all these junk words, right? These junk words are not needed. Where Pfizer is needed, inhibitor is needed, safely is needed, but these words are not needed, right? Phase is needed, right? So these only important words are needed when you are actually doing sentiment analysis. So classification, basically sentiment analysis means classification. So depending on the task, you need to perform different activities. It is always not true that you need to remove stop words. Okay, got it? So tokenization, token, instance of characters. Example, friends. Okay, term, right? You need to understand these. This is terminology, right? I am going to use these terms in, throughout the NLP. Token means any word in the document. Term means, like normalized word, the root word. Okay. So friends is a token, but term is a normalized word. Okay. If you see state of the art, co-education, lowercase, for these three tokens, the terms are going to be like this. State of the art is going to be state of the art only, but co-education can be written in different ways. Co-education like this and like this also, right? There is a dash in between. There is no dash. These kinds of words are going to be there in the document. If there are 1,000 documents written by multiple people, some people may write like this, some people may write like this. So you need to map them to a single word like this. This also comes under text normalization. And lowercase, right? A sentence, a word lowercase may be written in three different ways: as two words, as one word, as one word with dash. But you need to. This is all mapping, right? You need to create this kind of a mapping and then convert these mappings in whole data. That will actually improve a little bit of accuracy in the model. Okay, San Francisco. This should not be split into two tokens, right? All the NLTK modules are actually splitting that into two tokens. Okay, we'll see. Spacey will not do that. Especially entity recognition module will not do it. So stop words you already know. Right? Lexical and morphological analysis. You need to understand the terminology and remember. Okay. This image is not coming. Why I don't know. Give me 1 second. Yeah, dot slash only. This is code. Oh, I am showing this file. Give me 1 second. Find that file. This. Cool. Okay, so these terminology you need to remember. Okay, lexical analysis is the process of breaking down text into meaningful words and phrases. Tokenization, right? Lexical analysis is also loosely described as tokenization process also. If you see this, breaking down text into meaningful words and process, phrases. When you do tokenization, everything did not become meaningful words and phrases. But if you are carefully doing it, that is called as lexical analysis. Okay. When you actually read articles, right, they write tokenization and they write lexical analysis. You can actually remember tokenization. It is a simple word. They use lexical analysis, a complex word. There is nothing big in there. That's what I am trying to explain here. Lexical analysis is also loosely described as tokenization process. Remember, when you are reading some document or some book, if they write lexical analysis, it is tokenization only. Okay. And then morphological analysis, grammatical analysis of how words are framed using morphemes. Right? If you look at this, this is a whole morpheme. You call it as unexpected is a morpheme. There will be prefix, there will be stem, there will be suffix. These prefix suffixes are called as affixes. If you look at any book, right, they would have written 2-3 pages of junk on this. Just a simple image will explain that whole thing. So this is morpheme, prefix, suffix, and stem. Right? When you do stemming, right, this expect will come. Unexpected, expected, right? So in unexpected, it should not get expect because it's going to change the meaning. But no, I took an example here. Okay, so morphological analysis, grammatical analysis of words, right? This is the grammatical analysis of morphemes is called as morphological analysis. Morpheme means one complete word. Okay, so morphological analysis is used in word sentensization and POS tagging. Word sentensization means there will be a document with maybe many words there, but there may be sentences. You may have to split them and have a look at, right? So generally we never use sentensization much, but for word sentensization, morphological analysis is needed. Right? Grammatically, whether it makes sense or not, punctuation may give you sentence, but sometimes maybe 2-3 sentences actually make a complete meaning. Right? If you do grammatical analysis, right, you can actually divide it. So why are the NLP researchers trying to do all this? Is they wanted to give human-like capabilities in reading a document to computer. There are challenges. Still, there are many challenges in doing these things. Okay. Morphology is a branch of linguistics. Linguistics means natural language analysis using different scientific techniques is called as linguistics. Okay. Linguistics, natural, all are different terms. That's it. There is nothing. But when you actually look into the documents and the books, right, they'll use these terms. Right. Morphology is a branch of linguistics that studies how words can be structured and formed to form the sentences, complete meaningful sentences. Morpheme, small unit of given language is called as morpheme. Right? Morpheme may or may not have a meaning of its own, but words do, right, have meaning. So here, right, generally word means it will have meaning, but morpheme may or may not have, but it's a small unit of whatever this morphology. Okay, so terminology is important. That's where I kept it here. You read through it, remember it. That's enough. Okay. So pen is a word with one morpheme, but pens is a morpheme with two, right? Pen and s. Stem and root, we already have seen it, right? So this is more introduction about NLP. And let me jump into corpuses. Right? Before I go there, any questions? Any questions on whatever covered today? I'll explain what is corpus in more detail now. Can I move on?
Sir, one question, sir. Like you said that like NLTK will not use in the production, sir. So
Yeah.
what we are going to use in the alternatively?
This one, spacey,
Oh,
flare,
spacer, flare, or
stanza.
okay, stanza.
These three modules we'll use extensively. Even while practicing, I would recommend you to start with spacey. Then we'll go into flare and stanza.
Okay.
Stanza is basically Stanford NLTK only, but the code I wrote is, I wrote it in 2018, I think, 17 or 18, 18, I think, right? So that code is written on the when the module was like that. They changed the name and try to, kind of, these are all free modules that can be used in production.
Okay, sir.
So I will explore
So
that.
why NLTK is not used in production?
No, NLTK is not used in production. To understand concepts, I'll use NLTK. So there are some parsers and other things which we need to understand. So to explain that, there are some visualized modules which I will be using. But in production, we will not use it.
No, what are the disadvantages? Why we are not using it in production?
Code is not written production grade. It is all written by the university students, and it is for experimentation. NLTK was there for last 20 years. Initially, they did experimentations and kind of kept that code there for other people to experiment with. And we have more sophisticated modules now. If you look at spacey, player and stanzas capabilities, right? You will not use NLTK. There are no NRE modules, NER modules, or there are no modules which can be used to build production level code. You will understand why reason you will understand, because we'll see all the different ways of converting text into numbers. Those approaches are not there in NLTK.
Okay.
Okay, now let us try to understand corpus. You guys have got a little bit of a bit of understanding on what is corpus.
It's an input data. It's a set of documents.
Data for the model, right? Input data for the model, which is actually trying to intelligently work. Okay, but pre-built models. It is not for our model. It is for pre-built models. Corpus. Okay. Even we can also use. But it's rare that we may use. Maybe healthcare domain you are working on, and there is a corpus already created. You want to use it and try to build a model on it. Yes, we can. Right? Let us try to understand what is corpus, because in future, as of now, we are getting models which are already pre-trained on a particular domain data. But in future, right, along with the models, they'll give data also, in my view, because data is going to be available. The labeled data is going to be available. When I say labeled data, if you take 1,000 documents and you want to take each document and try to do parts of speech tagging, is that a tedious task? Do you understand what is parts of speech tagging? Did you understood what is parts of speech tagging? Do you know what is parts of speech tagging? Can you explain?
So noun, verb, adverb, kind of.
Yeah. So if you take a sentence like this, you need to tag it. First word as whatever, second word is whatever, third word is whatever, the fourth word is what. Like that you need to do each word. Right? You have 1,000 documents. Each document is of maybe 500, 600 pages. You need to take the 500 page book and then try to do the parts of speech tagging. Is that a tedious task? Is that a tedious task or easy task?
Today's task, sir.
Yeah, so the universities are actually doing that. Some of the researchers are actually doing that. Without that data, the language models cannot work. Language model cannot understand which one is noun, which one is verb, which one is adjective, and which one is whatever, right? If the language model is unable to understand or label, there will be problems. What is the problem we may encounter? I saw a bird in the trees, and the sawmill is cutting the wood. The saw has got two different meanings there. If the pre-existing data is not available, the labeled data, labeled corpus is not available, the model will not be able to understand which one is noun, which one is verb, right? So the scientific community, the universities are doing a lot of work there in labeling the data. Why am I reiterating labeling data, labeling data? In real time, you cannot use pre-existing modules as they are right now, because they would have trained on some data which may not be appropriate for your data set. A little bit of intelligence you have to add to the data. So you may have to label a little bit, may not be parts of speech tagging, something else. And then you may have to train the model. There will be training capabilities. These modules will have models which can be trained again, right? You need to have that thought process. For that, I'm actually trying to show all this. Okay. Corpus is a collection of digitized spoken or written content. The corpus is used for linguistic analysis or corpus analysis. What is linguistic analysis? What is linguistics? Here I wrote. Natural language analysis using different scientific techniques. Linguistics, different scientific techniques. That's the language trying to understand using different scientific techniques. Okay. So, example, if you are trying to build grammar correction system, what is needed? A corpus that already has got flags with grammar, right? We use a text corpus to find out the correct grammatically incorrect instances. So to do that, right, you should have some data which has got that intelligence. That intelligence will not come automatically. People should sit there and label it. Human labeling is the basis for AI. That point you need to remember. Either it is classification, or it is POS tagging, or dependency parsing, or any model is actually working intelligently. The human labeling is the basis. Okay, humans are giving intelligence to AI systems, artificial intelligence systems. So some people, so-called big people, are actually talking about computers taking over human beings. It will not happen, because we are actually inducing the intelligence to the computers. Maybe some idiot may create a machine which is distorted and may not have understood things, and it may create damage, but it is not taking control over the human beings. Okay, so because human beings are inducing the intelligence to the computers. Human being, how much human being can induce? How much he knows, but in reality, we don't have control over everything. Many things are happening on their own. If you see our life, right, only limited amount of things we have control over. Why? Because we know them and we are actually handling them. We are actually trying to induce our knowledge, whatever we know, to the computer and try to make it work. So the computers are never going to take over, because the human labeling is the basis for computer to understand. Even it is reinforcement learning, it is not going to understand. That's my feeling. Even after 100 years, computers will not take over human beings. Okay, so monolingual corpuses. There will be corpuses with only one language. Bilingual. There will be corpuses with two languages. There will be multilingual corpus. There will be multiple languages. Right? Why am I talking about this? We are working on a problem right now where documents are coming with English and other language. English and Turkish, English and Spanish, English and Italian, English and German. So if you have if you have a model trained on bilingual corpuses, English and other languages, you can use that model to understand it. Got it? So what is corpus you understood, right? We are actually trying to see, what are all different things. And corpus and its significance, where it is useful. A corpus is most critical and basic building block in an NLP application. Basic building block in an NLP application, because we'll be adding more to whatever the corpus knows, right? Corpus provide the qualitative data useful in building NLP application, right? Quantitative and qualitative. It is not about how many or how much. It is about how good the labeling was done, qualitative. Okay. Below are the things we need to consider while corpus selection. Right? If you are trying to build some application, right? Maybe healthcare or travel, or maybe trying to understand documents related to automobile or healthcare or travel. So before selecting a corpus, right, we need to look into this flowchart. Okay, type of data. What kind of data we have? Is the text or numbers or equations or HTML files or PDFs, right? What kind of data we have? Availability of data, and and the business area is very important. When I say availability of data, business. But if you are trying to work on healthcare data, healthcare text, do we have available healthcare text which is labeled already or not? Right, that is one thing. Especially this FLAIR, right? These models are trained on healthcare domain documents. Okay, the SPACY trained on healthcare as well as web data, Wikipedia data. They took Wikipedia data, they labeled it, and they trained on trained models. Or they actually used intelligent ways of vectorization, like word-to-vec transformers, and then trained models on that. Okay, either manual labeling or intelligent way of understanding semantic similarities. Quality of data, right? How good the data, how good the data labeling happened, right? That actually decides the quality. If Pennsylvania University professors have done the labeling, we can rely on it. But if some local company is trying to take, some English literature graduates or maybe studying now, we cannot rely, right? So the quality of data is also important. Adequacy of data, how much data we need to train, especially in the deep learning models, you need huge volumes of data. Small amounts is not sufficient. Okay, so do we have data to solve the problem? If you take an automobile industry corpus and you are actually trying to build a model to understand the data, or trying to extract named entities from automobile industry, you want to extract all the car names from the corpus, right? So some car names you may know, some car names you may not know, right? You cannot feed everything, upfront into a database, right? So you need to see, whether data is available or not, corpus is available or not. If yes, right, you go down, check the quality. You check the quality of the corpus, and then take your data and fix the quality issues and do feature engineering and build an NLP model. That's the way you go. If not available, right, is open source data available, right? Google Ngram, Brown data set, there are corpuses available there. Is that available, right? We'll see. Yes, then we'll come down, and then maybe if the label data is available, we'll do it. Or if not, right, if you have resources, right, you'll try to, if you try to label it and do. If not, right, collect data and then do it. So whenever you are trying to solve a problem, I have to update this flowchart. Is there a module like SPACY or FLAIR or Stanja available or not? All these modules, right? In all of these modules, any of them are trained on our business domain area or not, right? Business domain area or not, that we need to see. If it is, then you will take that and then try to build a model. So the approach actually changed a little bit. Got it? This is old flowchart. Got it? Do you have clarity, or even if you have a little bit of confusion, right, that's fine, because we are going to clarify the whole thing in the process of learning the other stuff. Any questions here on this flowchart and corpus thing? Okay, good. So there are different types of corpuses. You know, isolated corpus, categorized corpus, overlapping corpus, temporal corpus. The simple things. You know, this is all NLTK stuff. You know, in NLTK there are functions which actually show you how the corpuses are. NLTK has got many corpuses. You can download them. You need to download them like this. And then I have taken Gutenberg, right? It's in corpuses there is Gutenberg corpus. I'll show you example of why, you know, how a corpus is. See this, the tokenization is already done in this corpus. Right? In this corpus, I have taken one document and trying to see how it is present. Somebody actually took that data in this particular file, right, original file, and then they did this tokenization like this. Okay, and then there are many files in there, right? Again, tokenization here. There are Telugu and Hindi also. Let me show you that. See, this is all tokenization. Where is that Telugu, Hindi? So I actually was having Telugu and Hindi also somewhere. POS tagging also will be present. Let me show you here. Give me 1 second. It will be my old file. Okay, no, not here. Somewhere else I have kept it, and I'll show you that. Like, okay. So there are labels done for the around 15 Indian languages also. Okay, so by looking at the frequency distribution, right, you can actually do plots also like this. How many times each word occurred and all that. Okay. Now conditional frequency. These all things are not used now. Okay, so I'll upload this file. Try to play with it. And that's about corpuses and the introduction. Tomorrow we'll look into the what we call it, regular expressions. Okay, and once after that, right? Yeah, I'll actually take a bigger data set and try to do bag of words, and then hashing vectorizer, another technique to convert data, and then we'll see the topic modeling, right? And then we'll actually look into deep learning. I think information retrieval should also be there somewhere. Yeah, so that's how we go. So any questions?